Hey guys, so I came across something um, when searching on YouTube for stuff for tutoring purposes, and noticed that there are, at least not on the front page of the search results, videos going in depth about the arc-trig derivatives and why they are what they are. So I'm going to do a video on them just because there seems to be a lack of it, which is kind of unfortunate because these are kind of not intuitive. You wouldn't expect a trig integral to just be a normal function of x, normal being square root of a polynomial or just a quotient and stuff like that. So I'm gonna go over that and how to do that. Um, all you need to know is implicit differentiation and the normal trig derivatives to work through this. So we're gonna go ahead and do that. Um, so we're gonna start with arcsine first. So the setup that we're gonna have here is we're gonna set up a triangle, a right triangle that actually looks good. There we go. So we'll call this angle y, and we're looking for the sine function, the arcsine function. So we're gonna um, do it for the sine ratio. The sine is the opposite over hypotenuse, so we have x over 1. Um, and we could set up a ratio that relates y to x to find the derivative. So we know that the sine of y is equal to the opposite over the hypotenuse, which is x over 1. So we're going to take the derivative with respect to x for both sides, and we have to do implicit differentiation on that. So we take the derivative of this outside function, and we get cosine of y times the derivative of the inside function, which is what we're trying to find, dy dx. And the derivative of x with respect to x is just 1. So now we can divide the cosine over, given that cosine y isn't equal to 0. And for this purposes, that won't matter. For this purpose, it won't matter, rather. So we're kind of already like technically done. This is a correct expression for the derivative, but we want to find it in terms of x. So we need to find an expression for cosine of y with respect to x. Cosine of y is going to be this side over the hypotenuse. So we need to find this side using Pythagorean's theorem. So that means that we'll call this side a. This means that 1 squared is equal to a squared plus x squared. So a is simply square root 1 minus x squared, given that a is positive, which we can tell by the drawing it is. So this means that cosine of y, I'm going to expand the canvas here. Yeah, that should be more than enough. Oh no, that's not what I intended. Here we go. There we go. So this means that cosine of y is equal to adjacent over hypotenuse, which is going to be a over 1, which is just this, 1 minus x squared. So we can substitute that expression for cosine of y into the derivative we found earlier and get dy dx is equal to 1 over square root 1 minus x squared. But what is y? We established this relationship here, sine of y equals x. So we never actually explicitly wrote y as a function of x. But this is kind of the definition of arcsine. The definition of arcsine is y is equal to arcsine x. If this is true, the definition is that these expressions are equivalent. So we found the derivative for arcsine x, which is that. And the procedure is pretty similar for the other two, um, just with some negative signs here and there. So we're gonna go through arc cosine. I'm gonna draw the triangle up here just to give myself more room. Maybe make that a little bigger. There we go. So this angle's y, but now we're looking for cosine, so we're going to label the adjacent side x. This side 1, and this side is a. So now we have cosine of y is equal to x. For the same reason over here, it's just the ratio between the adjacent and the hypotenuse. So now we can differentiate. But remember, the derivative of cosine is negative sine, not just sine, so we have to include that negative sign on the sign. Negative sine y dy dx is equal to 1. So I'm just going to call it y prime. Same notation. Negative 1 over sine y. So sine y is going to equal a, right? For the same reason as here, except we're just flipping it a little bit. If you look here, up here at the triangle up top, the sine is going to be the opposite over the hypotenuse, which is a over 1. Using the same identity as before, 1 squared equals a squared plus x squared. We get the same result for a, which should make sense because there's symmetry in the triangle. So we get y prime is equal to negative 1 over square root 1 minus x squared. And of course, the definition of arc cosine is cosine y equals x. It's the same, the definition is that those statements are equivalent. So arctangent is a little bit different because now we're actually, we're going to be not really dealing with the hypotenuse until later. The hypotenuse is going to be, you'll see. So we're going to write a triangle out here. And again, this angle's y. Tangent is opposite over adjacent, so we're going to call this x, we're going to call this one, and we're going to call this a. So now we have tangent of x is equal to, or tangent of y rather, is equal to x. So we take the derivative of both sides again, and we get secant squared y times y prime is equal to 1. So we divide the secant squared over on the other side, but secant squared is just 1 over cosine squared. So when you divide that over, that becomes cosine squared. So we get y prime is equal to cosine of y squared. So we need to find the cosine of y, and the cosine of y is just going to be the adjacent over the hypotenuse. But we need to find the hypotenuse using the Pythagorean theorem, but this time the hypotenuse isn't 1, the hypotenuse is a. So that would be a squared equals x, I'm going to write it this way, 1 squared, which is just 1 plus x squared. We're going to leave it like that, and you'll see why. But to move on to the next step, cosine of y is going to be the adjacent over the hypotenuse, which is going to be 1 over a. So cosine squared of y, or cosine y squared, is 1 over a squared. And we came up with that up here, which is 1 over 1 plus x squared. So this is 1 over 1 plus x squared. And we've done it. Since y prime is equal to cosine y squared, we've shown that y prime is 1 over 1 plus x squared. And that's that. And of course, it's the same case with y equals arctangent x, because y equals arctangent x is the equivalent expression to tangent of y equals x. That's the definition of arctangent. So, hope you learned something. Have a good day.